We can decompose the following multiplication statements in lots of different ways. So I'm just going to show one way, but you can do it in multiple ways to do this. So if I'm going to multiply 17 times 13, what I can do is I can break this up into 10 times 17 and 3 times 17. So to do that, I can show that as 10 plus 3 times 17. This is going to be 170. 3 times 17. I could further break that down into 3 times 10 and 3 times 7. So 3 times 10 is 30, 3 times 7 is 21. So that works out to be 51. So 17 times 13, when I add that together, I end up with 221 is my answer. Okay, so we can do this in lots of different ways. I'll show two different ways for this one. So I can break this up into 4 parts. Okay, this is a little bit harder to keep track of if you're actually doing this mentally. But I can have 10 plus 7, 10 plus 3. Okay, so that's 100, 70, 30. So there's 221. So 32 times 15, there's a few ways this can be done. Multiplying by 5s or 15s is a little bit easier, so I'm going to keep that as 15, and I'm going to break that 32 into 30 plus 2. So let's move this over a little bit. And again, this can be done in lots of different ways. Okay, so I'm going to do 30 plus 2, and I'm going to do 15. So 3 times 15 gives me 45, and then I have the extra 0. 2 times 15 is 30. Okay, so 32 times 15 is 480. We can decompose 230 times 21. Okay, so again, I can do this in 4 parts. I can break it up into 200 plus 30 times 20 plus 1. Maybe I'll do it that way. If you are good with your multiplication, you might want to break this into 200 times 21 and 30 times 21. That would work as well. Okay, so I'm just going to break this up into 200 plus 30, and that extra one I'm not liking so much, so I'm just going to do 20 plus 1. So 2 times 2 is 4, and I annexed 3 zeros. This will be 600. 1 times anything is itself. So I end up with 4,830. 4,830. Okay, and again, you can decompose this in multiple different ways and get the same answer. So lastly, if we have this problem here, this is just a kind of a problem what we can work. This is a little bit more challenging, but we can kind of think of some ways we can do this problem. So we have AC, our digits, and times BB equals 396, and we know that the 3 digits add up to 6. Okay, so we can do this as, well, we have to kind of think what two numbers multiplied together, C times B, ends with a 6. Okay, so C times B being single digits ending in 6, well, it could be 4 and 4, 2 and 3, and we can start having guesses like that. So the one-digit numbers that multiply to 6 are 6 and 6, 4 and 4, 2 and 3, okay, and 7 and 8. So if we have 7 and 8 or many of those other combinations, that's going to add up to too big of a number. So we know we're dealing with smaller numbers. So we're probably going to be dealing with 2 and 3. So let's guess. Okay, so we're going to guess B equals 2, C equals 3. That would mean that implies then that A equals 1. So let's try that out. 1, 3 times 22. Okay, so when we multiply that together, we're going to end up with, well, I'm going to need my grid multiplication here. 20 plus 2 times 13 is 260, and 26. So that's going to be 286. Not big enough. Now what we could do then to make this a little bit bigger is we could maybe we can switch the B and C around. Okay, and we still have the same property. So B equals 2, B equals 3, C equals 2. And that still implies that A equals 1, okay, based on this statement up here. And then we can test this out. So we're going to do another guess. So it's going to be 12 times 33. Okay, so when we do 12 times 33, that's going to be a bigger product than that. And maybe we're going to get up to 396. So we're going to do 30 plus 3 times 12. That's 360, 36. There's our 396. So we use some deduction. So A equals 1, B equals 3, and C equals 2. Using some deduction and some limiting properties, we can solve a problem like this. So this is just kind of a problem that makes us think about how these numbers work and interact together.